All right, we're back. A little technical difficulties already. Yay. So I hope you all enjoyed the little break from this course, even though you were probably working on homework 3 during that time. I know I enjoyed the break. It was nice to only have 2 classes for a little bit. Now we're back into it. So homework 4 is out. We're going to cover the homework 4 content in 2 weeks. And honestly, it's probably, actually looking at this, probably just this week is going to be everything that you need for homework 4. So I want to go through homework 4, take a look at the last homework assignment we're going to do for the project, for the course, and then the rest of the course is stuff about the project. We can talk about the project during lecture time and things like that. Then some just kind of random topics. Like eventually, maybe next semester, HTTPS. I was thinking of doing it this semester, but there's, I'm burnt out. Adding this to homework 4. That's why it's in the homework 4 content, just not part of homework 4 this semester. Adding Nginx to your Docker Compose, and then creating a self-signed cert, and then getting HTTPS on your servers. Not happening this semester. But I will talk about it. I'll still cover the lecture content. I'm just not going to force you to do it on the homework. It's the only difference. I'll still show you how to do it, although I'm just not going to force you on the homework. I always like in my courses, I think I've said this before in this class, but just a reason why some of this stuff, I always like for the last homework to back off a little bit, especially since in this course we do have a group project, that I want you to start shifting your focus on the group project and stop getting hammered by these homework assignments. Assignments 2 and 3, that's where I'm really hitting you hard. That's where I'm saying this is where you're going to learn all the stuff and implement some complex material. Homework 4 will back off a bit. And the project honestly isn't too difficult, especially since you get to work in a team on it. At least half of the difficulty of the project is the reports. So going through all those repos, looking for the code, and dispelling the magic of these libraries that you're using. So we'll shift focus into that real quick once we get done with the homework 4 content. So let's talk about what homework 4 is. First, a visit counting cookie. So every time a user visits your site, you're going to track the number of times they visited your site through a cookie. So when they visit your page for the first time, you're going to identify that by looking for this cookie that you set. If it's not set, set it and set it to 1 visit. This user has 1 visit, and then display somewhere on your page the number of visits. You can just steal this code, put this in your HTML template, or display whatever message you want. You can modify that if you want. So set a cookie to track that, and then if the cookie is, when you get a request and that cookie does exist, increment it by 1, reset it, and then display that number of visits. So since this is working by cookies, it should be different for each user. So if you open a different browser, they should be able to see number of page visits 1, for example. For testing, we're going to clear the cookie. We're going to visit a few times, refresh, and then visit the page again after deleting the cookie, and then make sure that the visit count resets to 1. So I want to make sure you're reading the cookie header and parsing that and figuring that out, how to do that. There's a directive on this. There's a directive. Oh, no, that's the later one. No, there's a directive on this. So these cookies have to expire in at least 1 hour. So you have to have some expiration time on this. It can be 50 years or whatever, but it has to be at least 1 hour, whatever expiration you choose. So 1 hour, it's long enough that it's not going to expire during grading. I mean, we don't need a full hour, but an hour is overkill, but hey, an hour will work. So why not? So you do have to set the expiration time, meaning that this cannot be a session cookie. So there is a close the tab and then reopen the page. We're going to talk all about cookies. This will make more sense after today's lecture. You'll be able to do objective 1 after today's lecture, but it can't be a session cookie. It has to have an expiration time of at least 1 hour. Next, authentication. This is probably the big objective for this homework, and admittedly it's not too big. It's not like objective 2 on the homework that we just had, homework 3. Objective 2 is the bulk of the difficulty for homework 3. For this one, it's still probably the bulk of the difficulty. It's just not as demanding as either of the previous 2 homeworks. So authentication, add 2 forms, a registration form and a login form, just like you see on most websites, except I do not, yeah, that's what I want, open the dictionary, except I do not have a requirement that you have to have 2 password fields and the passwords have to match. I didn't add that requirement to this, so you can just have 1 username and password field for registration, 1 username and password field for login. When they register, You're going to have to store users' passwords. This is going to be the big topic of this, I guess this week, mostly Wednesday and Friday. Storing those passwords securely. We don't want to store passwords in plain text. Hopefully you've heard that before in your life, in your careers. Never store passwords in plain text, but we're going to talk about exactly how to store them, how you're going to put these passwords in your database, and specifically we're going to salt and hash those passwords. So make sure you're salting and hashing those passwords. You're allowed to use a library for that. I recommend bcrypt. That's what I'll use in the lecture examples. And bcrypt does most of the heavy lifting for you. And you just got to take whatever bcrypt spits out and store that in your database, and then use that for matching. I don't want to project the image that you should be writing your own hashing algorithms and stuff like that. There are certain aspects that you just need to defer to people who've spent a lot of time writing a library, and defer to them for the security aspects. Arguably, you shouldn't even be writing your own password managers at all, handling your own passwords at all. Defer to whatever library or whatever third-party service, login with Google, for example, to handle login. It is a very sensitive topic security-wise, and if you mess anything up, you'd have a big security hole. So it's always helpful to defer whenever you can. We will defer to bcrypt for the actual hashing and salting, but we will be handling our own passwords in this class, so you get an idea of how that works. And then just display a message on your home page. On the page that loads after you submit the login form, whether the login was successful or not. And we'll try it once with the correct password and once with an incorrect password for testing. Objective 3, password requirements. Have some password requirements. Not too much to say about this, but all these checks and anything you want to add to this, so all the standard checks that you see on pretty much every website these days, plus any that you want to add if you want to add more criteria to that, or like increase the minimum length. Have these password criteria and have them checked server side. Have them checked on the server, and if the password is not meeting all of these requirements, make sure you send a message to the user that says, hey, you didn't meet all the criteria, try again with a better password. Yeah.
Does this have to be like a WebSocket where it's constantly saying like this isn't working, this works, or can it be like a when you submit the password goes through and then you just send back a no?
So I'll stick with the wording that I have here. If you submit and not all criteria are met, you just have to send a message that says not all criteria are met. So you don't have to individualize like these criteria were met and these weren't. And you don't have to have the live thing like as you're typing, it marks the criteria that are met. You don't have to have any fancy features like that. Just something that checks server side and gives a yes or no. This password is good or this password is not okay. For usability, for UX, we like all those features, but for this objective, not too concerned. And it's typically not WebSockets, just a side note. It's typically not WebSockets when you're typing in your password and it says, it starts checking off the criteria as you type. That's going to be JavaScript on the front end that does that. That doesn't go to the server every single time. Typically. I'm sure there's some website out there that does go to the server every time, but typically you would do that JavaScript. No security in that, but that's strictly a UX feature. Like you could remove that JavaScript, have it say, okay, you met all the criteria, submit that password, and the server will still reject it. So there's the front end checks just for UX, and the back end checks for security. So we're only concerned with the back end checks, just sticking with the theme of this course. We're only concerned with the back end stuff, so we're going to skip the UX stuff. Which is, this is a couple conditionals, a handful of conditionals. I think that objective's fairly free, especially for this point in the semester and this point in your careers. Objective 3 shouldn't be giving anyone too much trouble. And then authentication tokens. So when somebody does log in successfully, add. Oops.
I've got a question about that. Should we just be adding that to our API?
So are you referring to the API in homework 3? So we're not going to use that API for. We're not going to continue using that. Just because I don't like the cascading failure. If somebody didn't get the API done on homework 3, I don't want that killing them on homework 4. Okay. So we won't use that same thing. This will just be username and password instead of email and username. So authentication tokens, add tokens. When somebody does log in, give them a secure cookie. Well, let me define secure for that. Set a cookie with their auth token. Oh, I do have to change this. I have to change this a little bit. It cannot be a session cookie. Here. It should be must. Yeah, this can't be a session. It doesn't make sense for that to be a session cookie. So if they log in, set a cookie that's going to be their authentication token, which is going to mark them as logged in. You're going to add that token to your database along with the username for this user. And then whenever you see that cookie, somebody makes another request and you see that authentication cookie set, you're going to take that cookie, the value of it, go to your database, check a hash of that, check the hash of that, check it if it's in your database, and check the username associated with that token. If it's in the database, pull the username, and then say this is this user. They are authenticated as this user. So if the token's valid, display their username, welcome them to the page or whatever, say welcome back. Or whatever message you want, as long as it contains their username. If the token's not set, or if the token is invalid, then did I say do the 403? No, not for this one. If it's not valid, what do I say? I guess just load up the regular page. It would be whatever you're serving in the previous objectives. So if the authentication token is not set or not valid, just display your regular page without this message. When you store these, only store hashes of the tokens. We'll talk about security, securely storing information. You don't have to salt tokens. We'll talk about why. But you do have to store hashes of them because that database with those tokens is very sensitive. It's as sensitive as passwords. Oh, I guess debatable, but it's on the same level as a database of plain text passwords if you're not hashing. And finally, set the HTTP only directive on this cookie. So HTTP only and the expiration on these cookies. And finally, add another path, /auth. You can load whatever you want here, content-wise. If the user is authenticated, return some page that contains their username. If they're not authenticated, give them a 403. Again, I think this Objective 5 and Objective 3 are probably the free-ish ones, the freest ones. And the other ones, you got to build some functionality and get practice with cookies and make sure your database is working. There's a lot of database storage required for this one. And that's it. I don't think I pointed this out in lecture before and actually forgot to add this to homework 2. But if there's a security risk, that is a 0 on the objective. Security is absolutely critical for any web apps. So if you have a security violation, it's an auto 0 for an objective. I forgot to put that on homework 2, so those of you who got 0s for security risks, I actually changed those to 1s in the grade book. But on homework 3 and 4, where I remember to put this in the grading, security is always a 0 for that objective. Security, if you can have the most wonderful, fantastic web app in the world. You deploy it to your users and there's security holes. That app is garbage. Like that's doing more damage to your users than anything good that it's doing. That's absolutely horrible. But if you have like a mediocre or a kind of crappy app that is absolutely bulletproof when it comes to security, you're actually doing something good. You're providing something for your users. It might not be the best experience, but as long as it's secure, you're not harming your users. If you're putting out insecure software, insecure web apps, that's, I haven't done my job at that point. So security is always absolutely critical. All right, any questions on the homework? Besides how to do it? Let's talk about how to do it. Oh, I didn't know that. Lights. 1 week and I forgot how to do everything. All right, let's talk about cookies. So there's a few instances where we have to use cookies for the visit counter and for the authentication tokens. There were 2 points in the homework where we needed cookies. So let's talk about cookies. So HTTP is stateless. We said this quite a bit throughout the semester. With this, actually I do want to talk about this a little bit because it probably makes a lot more sense now that HTTP is stateless. It's kind of a phrase that doesn't have much meaning until you really get practice with it. And now that you have tons of practice with HTTP, when you get an HTTP request, your server doesn't do any pre-processing at all on that request. You go right into reading the request itself. You read the request line, you read the headers, you read the body of the request, and that's all you're reading. You don't get an HTTP request and look up information with that request. The very first thing you do when you get a request is start parsing it. You start parsing the request line, what's the path, etc. That's because this is stateless. There's nothing that you read beforehand. For example, WebSockets is not stateless. There's some information you have to look up. Okay, I got some bytes over this TCP connection. Is this a WebSocket connection? You're doing some processing first and deciding how to handle that based on the state of that TCP connection, whether or not it's a WebSocket connection. And if we use the continuation frames, where we didn't just, like in the homework, we assumed that every frame was I forgot what the bit's name, but that very first bit that says this is the last bit, this is the last frame of this message, we can't assume that that's set in general. So that would be another part of the state of a WebSocket. You can get multiple frames with the same message. So we have some sort of state. Same with TCP. You can get different packets with different sequence numbers that are all part of the same message. It's all part of the state. HTTP, not the same. You get one request and you handle it in complete isolation. You don't say, oh, this is a CSS request for that user who just requested the HTML. You don't link those together at all. You treat those as two completely separate requests, which may or may not be from two completely separate users. There's no concept of state in HTTP. So this is kind of bad because often we do want state. Like with authentication, we want state. Like that's inherently state. We get a request and we want to say, who sent this request to me? And whoever sent me that request, I want to serve them different content. I want to decide, based on some information outside of the request itself, I want to decide how to serve up content to this user. So we do want state. Like the world that we live in, the world that we explore, the virtual world, the internet world, we do want state as we browse the web. We want this, we kind of need this to experience the internet the way that we know it today. So we want state. And this is where cookies come in. So cookies are going to give us that state. It's kind of a pseudo thing. It's kind of made up a little bit. It doesn't strictly add state to HTTP, but it kind of does. Like we kind of make things up and make it simulate state. So the way cookies work is we're going to set cookies, and that user, after we set a cookie, is going to send that cookie back on every single request that it makes. So if we set a cookie, we say, hey, user, here's a cookie. It's going to send that in every single request that it makes after that. So we can start identifying this user and saying, okay, I gave this user over here this cookie, and then I got a request over here with that same cookie. It's probably the same user. So this is how we can add some sort of state. And with the visit number, we're doing the very first thing with that. We're going to set a cookie and then change that cookie, update that each time we get a request, so we can track some information about a user. Cookies work through headers. So let's see the mechanics. You've probably heard of cookies. I assume everybody here is aware of what cookies are. But let's start talking about the mechanics of those cookies. And they work through HTTP headers. So if you haven't written that header parser, my goodness, if you haven't written a header parser by now, but if you haven't written a header parser for your server, this is the time. This is like the last chance to write that header parser. But if you have written the header parser, there's going to be headers labeled cookies, and you're going to pull those out of your key value store, grab those cookies. So they work through headers, which does imply that cookies are ASCII only. So ASCII only for these, for any cookie ever, can only be ASCII because it works through HTTP headers, which can only be ASCII text. And these are the two headers that we're concerned about. These are the only two headers that we care about with cookies. Through these two headers, this is how cookies work. The set cookie header, your server is going to add this header to the HTTP responses that you send to the user, and it's going to tell the user, hey, set this cookie. This cookie, by key value pair, send this to me on every subsequent request that you send me. Store this locally and send it to me every single time you send me a request. Cookie is what the user, the client, sends to our servers. Cookie is going to contain all of the cookies that were set. And then through JavaScript, the user can actually set cookies as well. The client can set their own cookies. They can also modify their cookies, importantly. So the cookie may contain more cookies than what we've set through our server through setCookie. But these are the two headers, and that's it. That's, in a nutshell, how cookies work through these two headers. And some JavaScript that can also set headers, that can also add, just manually add to the cookie header without having to get a setCookie request or response. SetCookie in the response. So setCookie, we're going to set cookies by key value pair separated by an equal sign. So if we want to set a cookie of ID with this random string, setCookie ID equals done. SetCookie, we want to set that visit cookie. Say you want to name it visits in this case. SetCookie, visits equals 4. Add these as headers to your response, and you will get those cookies back on every subsequent request from that user. Not too bad with all the background we have with HTTP. Adding cookies to the top of all that knowledge, not too bad. Just playing with headers, a little more header magic. You can only set one cookie with the setCookie header. So if you want to set multiple cookies, and this is actually allowed, we won't get requests where this matters, but it does kind of break the idea of parsing all your headers and put them all in a key value store where you can't have duplicate values. But you can actually have duplicate headers with the same name. So if you want to set multiple cookies in a single response, you add multiple setCookie headers. Headers are not unique by name. You have multiple headers with the same name in the same response or request. So you would send multiple of them. Yeah?
And so to distinguish between the multiple cookies, would we be just looking at the values that are being returned?
Yeah, so each setCookie, I thought I had an example. It's kind of what I'm looking for. So you would see like both of these cookies, or the browser would see both of these headers in the response, and then it would know one of these cookies is ID, named ID, and one of the cookies is named visit. So based on the name of the cookie itself, that's how you're going to distinguish between them. So each setCookie header is just like, okay, this is my way of knowing that I have to set a cookie. I have to set a cookie named ID with this value. I have to set another cookie named visits with this value. So if you have to send multiple cookies on a single response, like when somebody's authenticating, no, that wouldn't happen. I'm trying to think, you wouldn't have to increment the visits cookie while they're authenticating. But if you do have a situation where you need to set multiple cookies, don't jam them. Like you would think, like my first guess, for example, would be to put a semicolon here and then another key value pair. It's not the way to do it. Multiple headers is the way. The reason for that is that we can have directives. We can have directives, but we're not talking about that yet. And then the syntax for the cookies, this is all in a single header. So when we get multiple cookies sent to us, they will just be in a header named cookie, separated by semicolons, the way that we would think, That's the first thought that comes to mind. If I want multiple cookies, separate them by semicolons. It's kind of how headers roll. Separate values by semicolons. That is the syntax for the cookie header. So when you're parsing, this isn't gonna, multiple cookies isn't going to break your header parsers the way I told you to, the way I advised to structure your parsers. You're gonna have one header named cookie that's going to have all of the cookies separated by semicolons. Yeah.
So, didn't you just say, so when we're sending it, we shouldn't use the semicolon?
When you're setting cookies,
Or set?
don't use the semicolon. And we never send cookies to the user. We only send the instructions to set a cookie. And then the browser handles all the cookie stuff. Like, we don't handle anything with cookies as servers. We just set them and forget about it. And then when we get a request, then we're going to say, oh, cookies. Where did these come from? The server completely forgets that it set those cookies. Just the way that HTTP is stateless. The server's going to completely forget that it set those cookies. There's no way of verifying that you set a cookie in your server itself. But you're going to get the cookies, parse them, and then verify if they're legit cookies or not. Or in the case of visits, who cares? If somebody wants to change their visit counter, they can. But if it's an authentication token, we want to verify that. But we have no way of knowing that we set the cookies. And so we never send cookies. We just say, hey, set this cookie, and then we just hope the browser does what it's supposed to do with that set cookie header. But when we receive cookies, this is the format that the browser is going to send the cookies back to us. So you can, if you go to the browser console and do document.cookie, you're going to see all of your cookies. You can go view all the cookies in the browser console. You can, importantly, change those cookies. You can add new cookies. You can do anything you want with these cookies as a client. The client can do anything they want. So, as you've heard before, never ever trust your client. Anything that's sent in an HTTP request, you cannot trust any of that content. You have to verify everything. Cookies are no exception to this. Any cookie can be spoofed, can be made up. The client can do whatever they want with their cookies. Don't trust those cookies. Always verify, except, of course, in the case where it doesn't matter, like the visit counter. If somebody wants a visit counter that says you visited this site 1,000,000 times, I don't know, just let them, I guess. Unless you have like a 1,000,000th visit prize where you're giving them a car or something, If there's no security implications, don't worry about it. But never trust your cookies. If it's important that that cookie is legit, do not trust it. You have to verify that you were the one who sent that cookie. And we'll talk about how to do that when we talk about authentication tokens. The way to do it is send a very random string, and then if you see that very random string again, you can be reasonably assured that you're the one who generated that, because somebody wouldn't be able to guess that string if it's very random. It's hard to say that without using all the terminology. It has to have high enough entropy. So the users can mess with those. If you go into your browser console, just go to any web page and go document.cookie. It'll print out most of your cookies that are set for that page, or you can view them in the browser console. So users can mess with them, which means if somebody hijacks one of those authentication tokens, we're going to set that authentication token for a user through a cookie, and whenever we see that random string again, we're going to say, oh yeah, I know who you are, and treat them as that user, as they're logged in as that user. So if somebody steals that cookie, sets that cookie, and sends us a request, we're going to treat them, as we should, as that user for whom we've issued that token. They don't need to steal that user's password or anything. They don't need any of that. If they get that authentication cookie, that authentication token which is stored in a cookie, they don't have to hack your password or anything like that. They don't have to guess your password. They are you at that point. So we want to make sure we're verifying those. And we'll talk about that more in depth on Wednesday. But just a little foreshadow of how we're going to end up using cookies. The visit counter is just practice with cookies. Authentication tokens, that's what we really want to talk about. That's really where we want cookies. So to help with this, we can add directives. And this is why we can't set multiple cookies with a single set cookie header, because semicolons reserved for specifying directives, which are additional instructions for the browser about this cookie. So additional things that say, hey, set this cookie and follow these instructions when you're setting it. There are a handful of directives that we can work with. an expiration. We can set an expiration date through expires, which is expires, colon, and then the timestamp, the ISO. Is that, I don't know, it has to be in this format. It's a standardized, I think it's ISO date string. But it has to be in this format, and then after that time, after that date time, the browser will delete that cookie and not send it to our server anymore. This expiration date isn't sent to our servers. These directives are not sent in the cookies header. So we don't remember when these cookies are going to expire unless you add it to your database. But after that expiration date, the client will no longer send that cookie. The browser will delete that cookie. We can also specify a max age. This is recommended for your homework. You can also set a max age, which says this one in number of seconds after the cookie was set, when it should expire. So 3,600 seconds, I'm saying 1 hour, let this expire. So for your homework, this is, if you want an expiration of 1 hour, max age, 3,600, in 1 hour that cookie is going to expire. Yeah.
Do cookies have a default expiration date?
They do. And that's my next slide. If you don't set either of these, if you don't use expires or max age, the cookie will be what's called a session cookie. That's why I had to update the assignment as well. I had to remove the word session from that cookie, from the auth token. It'll be a session cookie which will last until that browser tab or window is closed. So as long as that user is in that specific session of visiting your site, that cookie is going to be set. But as soon as they're done with your site, they click that X, it's gone. So this is the default behavior if we don't use expires or max age. Neither of the cookies for the homework are allowed to do this. You have to use, I would just use max age. If you want to do expires and have it sometime after the time you know we'll be grading, you could do that too. But max age of an hour is the easiest way to make sure. Because we're going to close the tab. It's in the testing procedures. Go through your testing procedures before you submit. If you close the tab and that cookie doesn't persist, it means you forgot your max age. Yes?
So when we like log into e-commerce, for instance, we say, remember, for 7 days, setting a cookie with that expiration date.
I think that's server side. I keep meaning to hack that because I'm like, I just want to be remembered forever. I think that's server side checks. But I do want to double check that because if it's as easy, because you can go into your browser console and change the expiration dates. If we can just, has anyone tried this? Has anyone verified this? Because I keep meaning to, but then I forgot, keep forgetting. Change that cookie from expires in 7 days to expires never before Duo. Can we get around Duo? I don't think we can. I find it hard to believe that a group of developers at Duo at any company, could sit down and have, defeat the whole purpose of their app like that. But if they do, I would take advantage of it, personally. So another directive, secure. If you set the secure directive, that cookie will only be sent over HTTPS connections. So it will not be sent unencrypted. It's important for the internet, of course. It's not something we can use on our homework because we don't have HTTPS. So maybe someday when we, a future version of this course where I add HTTPS with self-signed certs and Nginx, we'll do that. This semester, we don't need to. But if you see that secure directive, it means it's only being sent over an encrypted connection. HTTP only, this one we will use, means you can't modify or access this cookie using JavaScript. This is important for any JavaScript injection attacks. If the cookie is HTTP only and somebody injects JavaScript into your machine or has JavaScript running on another site trying to read your cookies, not on another site, that doesn't make sense. But if they inject JavaScript into your site and try to hijack those cookies, HTTP only is going to say, nope, we're only letting HTTP mess with these cookies. Your JavaScript cannot mess with these cookies. When you do document.cookies, I said this will display most of your cookies. It will not display any cookies with the HTTP only directive. So if you have any cookies with HTTP only directive, and you do document.cookies in the console, the HTTP only cookies will not be displayed. Or else they could be hijacked with a JavaScript injection attack. So it gives us another layer of security. Of course, we're going to protect ourselves against JavaScript injection, but if somebody happens to get through with a JavaScript injection attack, let's at least protect some cookies with HTTP only. These still can be changed through the browser console. So the user themselves can modify these cookies without JavaScript or HTTP. But the hijacker who doesn't have physical access to your device, they can not access those cookies, at least not through JavaScript. The path directive is going to only send cookies for a particular subset of paths on your site. This one, I find this one not very useful, but it's another directive, so I thought I'd cover it. I want to cover every directive. The path is only going to send that cookie for paths that start with this path. So anything that starts with the path post, this cookie is going to be sent to. But if somebody goes to just your root, your home page, this cookie will not be sent. Yeah.
For the path, where you have like path posts, if there's like another extension, like path
Yeah,
posts and then slash like.
Yeah, it just has to start with that. So if it's, like if you want to do this for images and you have like a query string after or something, you just do path/images and then it'll cover everything no matter what they're requesting. Then the same site directive, this one we can't quite use either. Same site, this is going to protect against our cross-site requests. So if somebody has a cross-site request, I might as well put the F on there, forgery, and they're making a request from their site. So if somebody else's site has a request that's going to say, hey, UB Learns, or let me do the bank example. Hey bank, transfer $100 from my account to some attacker's account. So I could put that JavaScript on an attack page, send everybody the link, and then that request is going to be sent to your bank and transfer $100 to me. That would be the attack. That's our cross-site request forgery. That's where we had those XRS, I always get the acronym, cross-site XSRF tokens from homework 2. That's where we have those tokens to prevent those types of requests. That's one line of defense. We have another line of defense that says, don't send the cookies from third-party sites. So if we say same site equals none, or hold on, let me make sure I say this right. If we say, I was going to say it wrong, same site strict. If we say same site strict, then that cookie is not going to be sent on those requests. So the whole idea of sending the request and saying transfer $100 is that that request is going to contain your authentication token in that request. The bank's going to verify it as a legitimate request from you and then make the transfer. If we have same site strict, that means that cookie is only going to be sent from request from our site itself. If they're navigating our site, that's the only time that those cookies are sent. And if somebody's navigating a different site, there's a different host making a cross-site request, we're not going to send those cookies. So that's what same site strict is. So strict just never, ever sends those cookies. So if you set your authentication tokens to same site strict, it's another layer of defense against those cross-site request forgery attacks. None means send this cookie all the time, everywhere. This usually web apps will want this when it's an advertising tracking cookie, for example. They want that cookie sent no matter what. They're going to have that cookie sent all the time. And lax is in the middle, where oh man, I forgot the rules. Then the default setting of same site is not sent. Oh, when navigating to your page, right? Sorry about that. So the AJAX requests from a third-party site are not going to contain those cookies. But if you're on a site and you click a link to your site, then those cookies are sent. So only when navigating to your site. We can't. Oh, I did. The none did have this backwards. I thought it was strict. The none has to have the secure directive set. So if you would have same site none, the browser is going to force you to use HTTPS only as well. Yes.
And so is the default value strict?
The default is lax, which is the cookies are sometimes sent on third-party requests and sometimes not. Any other questions on anything? I just realized this is my last slide. I thought I had one more slide after this. Yes?
Should we just be generating a random
Yeah.
person?
Yep. And we'll talk about that on Wednesday when we talk about authentication. Oh, on Friday. We'll talk about the tokens. So we're going to generate a random string similar to how you generated your cross-site request forgery tokens. We're going to generate a random string that's long enough. We will have security measures for this one. Long enough. I guess I didn't specify that in the homework though. Long enough, I'll put it in quotes, that nobody's going to reasonably be able to guess it. So if they're long enough that people can't guess it, then we're going to call it secure. Why not? Yes. Yeah, which doesn't have to be secure at all. But yeah, in general, and we'll have ways of measuring that. We'll, I think I'll talk about it in next Monday's lecture. We'll have ways of measuring how, well, like what's long enough. What's going to be a long enough string that we have enough entropy that we can be reasonably assured nobody's going to guess it. Yes.
You just said like for the visit cookies, we don't need that to be secure. That doesn't mean like our security is still good. It's just that cookie doesn't matter if someone.
Yeah, for that one, we're not concerned. If somebody hijacks that one, it's like, we don't care that much. For the authentication tokens, we care a lot. The visit cookie, I just had that objective for you to get warmed up with cookies before jumping into the auth token. The auth token is what we really want to talk about. Auth tokens, like that's how the internet works. That's without that, the whole internet would not be very interesting. If every single time you made a request for a site where you have to be logged in to use it, you would have to type in your username and password every single time. Every single time you want more content to load, every time you want to post a message, every single time. Authentication tokens get rid of that requirement, really make the internet usable. There are sites that I logged in years ago, and I'm still logged in because that token, that cookie is still set, which makes the internet much more usable. Opens one security risk is that if somebody steals your laptop, they have your cookies. But if somebody steals your laptop, you have bigger issues, I think. You got a lot of issues at that point. And you should have a password on your laptop anyway, so they can't get your cookies. But your roommate can steal your cookies. Just remember that, if they're savvy enough. All right, any other questions? All right. See everybody Wednesday.